Right, so we look at the how to draw an image in a plane mirror. Okay, it's a useful tool, skill to have. It relies on the law of reflection, which is one of the easier laws. It tells us that that is a text box. It tells us that the angle of incidence is equal to the angle of reflection. Okay, don't forget, if you've got a mirror, first thing you want to draw on there is a normal, which is 90 degrees to the surface. Okay, as a ray of light comes in, the angle between the ray and the normal is the angle of incidence. Okay, so it's going to be in that way, and it gets reflected off there. So there is our angle of reflection. Okay, so we're going to use that law of reflection to help figure out where an image is going to appear in a mirror. Okay, so there's our mirror. Okay, first thing we need is an object, and then we're going to draw a ray of light off one part of the object. So I always choose that bottom corner, and I've got my first ray. It's just a straight line from the object to the mirror. What do we just say? We always got to add. First thing to add is a normal. If we don't know the normal, then we won't know what the angle of incidence is. Okay, so we draw our normal, we find out what that angle of incidence is there. You measure that, let's say it's 30 degrees, seems about right. You measure that, and then you draw the second line. Okay, so if this one was 30 degrees, then because of the law of reflection, this one's 30 degrees. Okay, and then you draw your line. Now the next trick is that we extend this line backwards into the mirror. Okay, so you put your ruler on this part of the ray. Okay, there's our ruler, and you extend it in. Now obviously this is a ruler, by the way. There you go, it's got much on it. So this is obviously going into the mirror, so we also have to remove the mirror at this point from our bit of paper. But we basically put our ruler, seen some rulers like this, those flexible ones, along the ray we've just drawn and extend it into the mirror. Okay, with this dotted line. The next bit is the bit that people tend to forget, is we need to draw two rays. So we draw a second ray, but we draw it from the same point. Okay, if we do it from a different point, the system doesn't work. Then what do we add? Well, we add another normal. Okay, we add another normal because we need to know that this angle of incidence is 45 degrees, for example. We know what that angle of incidence is, law of reflection. Okay, this is 45 degrees. We know our angle of reflection is also equal to 45 degrees. Okay, and then we're just repeating the process. We get our ruler, we place it on the line we've just drawn, we remove our mirror, and extend it into the mirror. Notice these are dotted lines. Okay, because they're not real. They're not real rays of light, they're virtual rays. Okay, so that's why they're dotted. The normal's drawn as a dotted line, it's also not a real line. So you just try and get into the habit of doing those lines as dots. Now you might find that your lines go on a little bit further. Okay, mine finish in perfectly the right place, but you might find your lines go a little bit further. And the reason you draw them a little bit further is because we're interested in the point where they cross. Because the point where they cross tells us where the object's going to appear. Tells us where that bottom corner is going to appear. Okay. We could have taken it from up here or down here. In fact, if you really wanted to, you could take it from all of those three bits, and what you'd find is you'd get the same crossover. But remember, you've got to do two. Okay. One of the easiest rays to draw is this ray. Okay. Because here the angle of incidence is 0. Not sure why we're yellow, why we're green, but never mind. So the angle of reflection equals 0. So it's a nice straight line. So you should see that your object is always in line with your image. Okay? Similarly, we could have drawn a straight line from the top. But remember, you must have lines crossing, because it's where the lines cross or intersect, if you're feeling posh, that we're interested in. Okay? Other interesting things, this distance between the object and the mirror is the same as this distance, the object between the image and the mirror. So we're going to use that fact in a second. So if that was 5 centimeters, that's 5 centimeters. Okay, and we're going to use that method to help us do it right every time. Okay, I've called it the alternative method. I have to call it the cheat method, but it's not really cheating. So I'm doing this sort of with the ruler, hence the sort of slapping noises. So the first thing I'm going to draw is my mirror. Okay, then I'm going to draw my object. And then I'm going to measure how far the ruler is. That's 30 centimeters for me. Okay, so I'm going to go into the board another 30 centimeters. Okay, so now that my object is going to appear there, my image rather. Okay, so these are both 30 centimeters. Now what I can do is I can draw my first ray coming off here. Okay, and it's going to be virtual, don't forget. So it's dotted. It stays dotted until it reaches the outside where it becomes straight. And actually what we then do, is the clever bit, is we join up the emergent ray with the corner of the object. Now they're slightly off, and I apologise for that, because the calibration of my board is slightly off. But I can then repeat it with a different ray. Same thing, dotted line down to the image, down to the mirror surface, then straight down after that. Okay, and then what do we do? Well, we sort of have to backwards add our normals, because that's just good practice. And on there. And actually, if you had a protractor and you check that, I'd be fairly confident that the angles are pretty close to what they should be. It's not perfect because, as I said, the calibration's off. If you do this on paper, it should work really nicely, and you'll tend to get better results doing it this way than using a protractor and doing it properly. Why is that useful? Well, often you'll be given just one ray. Oh, it should be purple, never mind. You're often just given one ray, and then you have to do the rest. Well, let's say you were only given the blue ray. Okay, you just have that ray coming down there, then you find your angle in there and go off. But you could easily draw this line on here, measure this angle, measure this distance here, repeat the distance there. You know where that's going to be. Often in a question, in fact, they'll even draw the image for you. So you know there's going to be a dotted line all the way down to here, to the blue one, and then a straight line out. So you don't even need a protractor. Similarly with the purple one, okay, dotted line down there, straight out the back. Okay. It's worth practicing that. So you could just grab a scrap of paper and you could easily recreate that cheat method, alternative method, sorry. Let's just rewind the video, give it a go. What do we know? Well, we know the image is virtual, and that means it's not a real image, so it can't be projected onto anything. You can't project an image from a mirror onto anything, whereas something like a projector, funnily enough, projects a real image. And the image is laterally inverted. That's just means that the left and right are reversed, and you've just seen this when you wave at yourself with your left hand, your mirror buddy waves at you with their right hand, what appears to be their right hand, because the image is flipped left and right. It's like where they write ambulance backwards. So that's that really. It's not that tricky, but it's a useful way. It crops up more often than not. Okay, draw a line, draw a normal, find the angle, draw the reflection ray, extend it back into the mirror, draw another line from the same point, find the angle from the normal, find the reflected angle from the normal, extend it back, look at where they cross is where the image is. Okay, if you want to, the simplest line is that horizontal line. Again, if you've got 3 lines crossing, then that's even better, isn't it? Because you can be even more sure. So sometimes they'll ask, how can you prove the result? Add a third line, check it crosses at the same point. Okay, and then that's it. That's how you find whether the image sits inside a plane mirror.